So in this chunk, we're going to talk about our first clustering algorithm, and the clustering algorithm will be called the k-means algorithm. And on the right-hand side of this slide, we've got the pseudocode for the algorithm, and we're just going to spend the first part of this chunk just walking through that pseudocode. On the left-hand side, we've got a toy two-dimensional data set, which we'll be actually applying that pseudocode to, so you can see exactly what's happening at each step of the algorithm on the toy data set. Okay, so in comes the data set to our k-means algorithm. Again, remember this is n data points. Each one is a vector valued quantity where each one of the elements of the vector is real valued and the vector is d-dimensional. And just to visualize everything on the left-hand side here, our data set is going to be two-dimensional. And remember, we don't get labels to start with. All we get is these black data points, and the algorithm has to automatically figure out from those black data points where to lay down the clusters. We're going to tell the algorithm we want big K clusters. So the k-means algorithm is going to require you to specify the number of clusters. And in this case, we're going to tell it to try and extract 3 clusters. And roughly speaking, you can see by eye, they look like there's probably 3 clusters in the data. And so we might expect the algorithm to sort of try and put these guys together into one cluster, these points together into another cluster, and these ones into a third cluster. And we'll see whether actually the algorithm does that. Okay, so input comes in, which is the data set, and then we have to specify how many clusters it's going to return, which is 3 in this case. And the first sort of meaningful step of this algorithm is to initialize the parameters of the algorithm. And the parameters are going to be these MKs here. So we're going to initialize, in this case, 3 vectors which live in the data space. So they're d-dimensional. 3 d-dimensional vectors. And in this case, you can see them plotted here. This might be M1, for instance. This one be M2, and this one M3. These things can be called the cluster means or the cluster centers for reasons that will become obvious as we run the algorithm. The idea is that they will locate the center of the clusters or the means of the clusters. And we'll see them doing just that. So you initialize big K vectors, in this case 3 vectors that live in the data space, and now the algorithm is going to move around those cluster centers in order to try and put them at the center of the clusters in the next few steps of the algorithm. Okay, so that's the initialization step. Now we get to the heart of the algorithm, and the heart of the algorithm is iterative, so we're going to repeatedly apply 2 steps, one after the other. Okay, the first step looks like this. Okay, it says for each of the n data points, go through all of your n data points one at a time. And for each one, measure the distance between the data point and each of the cluster centers. So for instance, here we've taken this data point and we're going to measure the distance to this cluster, the distance to this cluster, and the distance to this cluster. And we'll use Euclidean distance here, although we could put in other measures of distance. And then we'll figure out which one of these distances is closest by carrying out a little argmin here. We're going to minimize, we're going to pick the cluster K for which the distance or away from it is the shortest, and then we'll assign it to that cluster. So the S attached to it, the cluster label, will be assigned to the closest cluster. Okay, so we just find the closest cluster center, and then we set S. In this case, S would be equal to 1, corresponding to this cluster here. And we do that for each one of our data points. And I've actually gone and colored each data point according to which cluster center it's closest to. So, you know, intuitively, all the ones down here are red because they're closest to this cluster center. Okay, so this step is called the assignment step, because you're assigning data points to clusters. Okay, so now we've done that for all of our data points. We then move to the step down here, which is going to update the cluster centers. Okay, so we've assigned data points to clusters, and now we're going to update the cluster centers based on that assignment. And the way we're going to do that is really, really simple. We're going to go through each of the K clusters here. So we're going to loop over the K clusters. And we're going to compute the mean of all of the data points which have been allocated to that cluster. So for instance, in this top cluster here, we were originally here, then we've computed the mean of all of the data points attached to that cluster. So that was all of these magenta colored data points out here, and that moves the cluster center to this new position here. And similarly, we've gone through all of the red data points down here, all the data points which were assigned to cluster 3. We compute the mean of them, and that updates our mean to this point here. This update is called the update step. So remember, this was called assignment, and this was called update. The update step changes where the cluster centers are, and you can see that the cluster centers are perhaps arguably moving more towards the center of each one of the clusters than they were before. Having done an update step, we go back to an assignment step. The means have moved now, so the allocation of data points to clusters will look a bit different. One thing I should just note here before we moved on, some people have asked this in previous years, is if no data points are assigned to a cluster, so the mean of a set which doesn't include any data points is sort of ill-defined, but you can get no data points assigned to a cluster. So for instance, if you initialize a mean way over here and your other two means are in here, your cluster centers are in here, then we'd have no data points assigned to this one out here. And we need to make sure we've got it defined what the algorithm does in that case, or else it will crash. In that case, the rule of thumb we're going to use is that if no points are allocated to a cluster, so this one that's way out here, it just stays put. So the mean of the set is just defined as the old value of the cluster center. Okay, so with that in mind, we can now go to the next step. That didn't happen in this case, so we don't need to worry about it for the current case. We go back to the assignment step, and the assignment step now will reallocate points to clusters, to cluster centers, and we get the current assignment that you see here. All of these ones in the middle here are allocated to this blue cluster because they're the closest points to it. All the ones at the bottom get allocated to the red one, and of course all the ones at the top get allocated to the magenta one at the top. You just allocate it to your closest cluster center again, and then we recompute the means for each one of those colored set of points, and plop, we get this update. I'm just going to run this forward for another assignment step. You can see that good things are now starting to happen. All of these points over here, and pretty much none others, are getting allocated blue. So in a minute, that cluster center is going to take a big hop up to the right. And the other two cluster centers are doing nice things. This one is grabbing most of the points in this cluster, and this one is grabbing most of the points in the bottom cluster. So it looks kind of hopeful that we're going to end up with a good sort of solution in a qualitative sense, and we keep iterating, flip-flopping between these two things, and we'll keep going until this convergence criterion is met, which is that the assignments are fixed. The SNs don't change to the cluster to which each data point is assigned to. Once that stops changing, we know the means can't change, the cluster centers can't change, the updates won't do anything, and so we've hit convergence. Okay, so that happens after some time, and this is the final clustering solution we get, and we'll sort of return to the user the following assignment of data points to clusters. It's pretty good. There's maybe one point that we might quibble with. This one got assigned to the blue cluster, and perhaps it should have belonged to the magenta cluster, but apart from that, this very simple algorithm has done a really good job. So in the next chunk, what we'll talk about is sort of technical theoretical properties of this algorithm. It's going to turn out, partly because it's nice and simple, that we can do some analysis on it. We'll start thinking about its properties and how to set up this analysis.